Okay, we're now recording. And let me try to share the screen as usual. Now, what I have in mind is for the second hour, at least some of the second hour, maybe the majority of the second hour, or maybe all of the second hour, I will have for review a questions and answer session in preparation for this Thursday's test. Okay, so again, the next exam, third exam, will be this Thursday, and that would pretty much represent the halfway point of our class. Believe it or not, this is week 9 out of 17, so it's about halfway. We're having 6 exams total, as you can see, so this would represent the halfway point. Okay, so I was scheduled to do 7.3, it looks like, since I was done with 7.2. I'll do 7.3. Okay, and second hour, I'll devote some of the time, or maybe half the time, or maybe all the time, to questions and answers related to the exam, if you have any. Okay, and I'll split it up between Mackenzie and Star and myself. Okay, where maybe some of you would be in a breakout room with Star, some of you will be in a breakout room with Mackenzie. I'll be in the main room if anybody wants to catch me in the main room, and it'll just be a question and answer session if you have any questions about the test. Okay, so reminder, the exam coming up on Thursday is chapters 5 and 6. Okay, so chapter 5 was not trig, it was still other pre-calc stuff, exponentials and logs, and we have a little bit of trig in chapter 6. Okay, so again, we're doing roughly two chapters per exam. The next exam after that would be pretty much all trig. Okay, so we're going 2 chapters per exam, right? We had chapters 1 and 2, 3 and 4. The next exam, which is this coming Thursday, is 5 and 6. I've already finished everything I need to cover from 5 and 6. Okay, as I've already started chapter 7. Okay, and then there's going to be exam for 7 and 8, 9 and 10, 11 and 12, or rather 11 and 13. Actually, a little bit of 12, and then we're done with the course. Okay, so reminder for the exam, you have to turn in the homework. So I don't grade your exam if you don't submit at least 70% of the homework from chapters 5 and 6. And frankly, that's not that hard to do because I end up doing a great percentage of the homework anyway, as you already know, right? So that shouldn't be that bad. Okay, so Thursday, I'll lecture maybe very little and then let you ask questions. Okay, again, on my syllabus, I only promise to give you 1 hour for the exam, but if you want more time, to just ask fewer questions, I guess. So that's why I'm letting you have a question and answer session today, second hour, some of the time, or at least half the time, or maybe most of it, or all the second hour, you can ask Star or Mackenzie or me questions about the test. And if you don't have anything, then you can just leave. And that's the way the second hour is going to be, okay? All right, and I think Star is putting something there. So if Star can, she can put something in the chat or send you all an email or Canvas announcements when Star might be available outside of class in preparation for the test. Okay, but for sure, I'm going to aim for the second hour to be a review session. That's optional. So you don't have to do that if you don't want to. If you say, I'm good, I know what I'm doing for the exam, then you don't have to stick around. But if you want to stick around second hour, depending on how far I get, then you can ask either Star or Mackenzie or me for questions relating to the exam for this Thursday, okay? So that's what's going to happen there. So you've already seen my exam, so you know the style. I tend to give about 10 questions, and I think I said this before. It looks like there's 10 sections. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a natural assumption is I'm going to give 1 question per section. Maybe that's all I'm going to do, but maybe I'll give a little bit more, a little bit less, but I tend to give about 10 questions. Okay, and again, in my syllabus, I promise, okay, first hour, I lecture and questions and answer, second hour, the test. But if you want to start the test early, you can, then just ask fewer questions, I guess, on Thursday. That's why I'm letting you have the second hour of today, and then we can maybe start the test earlier. That's what happened last time, and then you had plenty of time to complete the exam, hopefully. Okay, so any quick questions about the exam right now? Not specific questions about material, but just how the test works and so on. But you've seen my exams already, so you know the way it works. You should know I don't give any trick questions. I don't give any surprise questions. So if you can do, if you can do all this stuff and all this stuff, then you should be fine to test. And I've already finished all this, right? Since I'm already on to chapter 7. Okay, so I'm gonna go ahead, 7.3. I don't think it'll take that long to finish 7.3. In fact, a lot of it is material we've already seen. So just 1 to 25 odd, I'll do a bunch, okay? And then the second hour we'll devote to questions and answers if you have any, and if you don't have any, you're free to leave at that point, okay? So 7.3, it's only 1 to 25 odd. So for those of you that don't have the book and don't plan on getting it, okay, so sketch the angles and stuff like that. And then we have some matching problems. And evaluate by using the method shown earlier, okay? So we'll have to use our reference angles for that. And we had to go up to what, 25-ish? And there it all is. Okay, and I know I'm showing this to you fast, but you know, you can always look back at the video. If you want to see it, I'm just raising it to focus it, and you can always pause and press play and, you know, go forward or backward as frequently as you want. Okay, so here we go. So this is 7.3, page 499. Whoops, I don't really want green. All right, so it says sketch the angle and sketch the angle in standard position and specify the reference angle or reference number. All right, so 1 is in degrees, 3 is in radians. So I'll show you a couple of each and maybe 1 positive and 1 negative from each. Okay, so how about 1A has 110 degrees. So they want you to sketch the angle and give the reference angle. All right. 110 degrees. Okay, so I know this is 90, right? So our standard is we start from the right and go counterclockwise for positive. That's 190, so 110 should be somewhere here. Now, you don't have to get yourself a protractor. It's not necessary, just kind of eyeball it. 110 degrees. All right, the reference angle, again, is the angle made with the x-axis, the acute angle, positive acute angle that's made with the x-axis with this ray. So in this case, it's this angle. So can you figure out this angle? Well, if I go all the way here, that's 180 degrees, right? So this is 110. This must be 180 minus 110, which is 70 degrees. Okay, so I'll call it theta R for reference angle, 70 degrees. Okay, so I will subscript for reference angle theta with a little r here. I'm not going to put it up here because if I put it up here, that means radians. You've already seen me do that, although I'm going to be writing that less and less. Okay, so for the reference angle, I'll put the r down here. So the reference angle is 70 degrees. All right, that's all. Maybe I'll do a negative one. Okay, how about I'll do D? It says negative 60 degrees. Okay, negative 60 degrees means I go 60 degrees down. I might as well just use the same picture for this one. It's not that hard. Negative 60 degrees. So this is for 1D. Well, the reference angle is this, 60 degrees. All right. All right, that's it. Now you're probably less comfortable in radians. So let me try to do at least a couple of the radian ones. So 3, and there's some of them that are negative even. So maybe I'll do 1 negative and at least 1 positive because we're less comfortable with that. Okay. So 3 be negative 5 pi over 6. Let me draw my unit circle again. All right. So you want to know at least one basic one for 30 degrees. I already put this down. And again, you can put this on your cheat sheet if you wish. Pi over 6. And a reminder, for every exam, you're allowed to have one cheat sheet, one formula sheet, 8.5 by 11, standard sheet of paper like this. Okay, double side, you can write in the front and in the back. Put anything you want. Okay, pi over 6. And then what I like to do is go pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, right? So eyeball it. So 5 pi over 6 is over here. Right, so 5 pi over 6 is like that. So negative 5 pi over 6, symmetrically, I would go over here. So it would land me like this. So this is negative 5 pi over 6. Right, so one more time. This is 5 pi over 6. And we go pi over 6, 2 pi over 6, 3, 4, 5 pi over 6. I put this before. Positive. So negative would be like this. So this is my reference angle. So what does that look like? Looks to me like 30 degrees, which is pi over 6. So my reference angle or reference number, sometimes they say it, pi over 6. Okay. All right, how about 5 pi over 3? So where is 5 pi over 3? Oh boy. Okay, to me, the best way to do this, okay, I've already marked off every 30 degrees, which is pi over 6. So why don't I just keep going around a circle, make this equivalent to something over 6. So 5 pi over 3, multiply top and bottom by 2, is 10 pi over 6, right? And I just play the same game as over here. So break it up like that and like that. You can tell I'm not really being that accurate, but you don't have to be that accurate if you just want something quick and dirty. It's every 30 degrees, right? Pi over 6. Okay, here we go. I want 10 pi over 6. Pi over 6, 2 pi over 6, 3 pi over 6, which is the same as pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6. Maybe I'll just put key markers over here. 6 pi over 6 is the same as pi, right? 3 pi over 6 is our pi over 2. 7 pi over 6, 8, 9 pi over 6, which reduces to 3 pi over 2. Aha, here we are, 10 pi over 6, which reduces to 5 pi over 3. Okay, so the angle that I want is way over here, almost all the way around the circle. So there's the angle. And now this is my reference angle. That looks like 30 degrees. I'm sorry, 60 degrees. 2 30s is what I meant to say, right? 30 and another 30. What is that in radians? Well, every 30 degrees is pi over 6. I got 2 of them. 2 pi over 6, which then reduces to pi over 3. Okay, so that's what I want for that one. All right. Okay, then for 5, yeah, we'll do 5. It's based off of the table I gave you before. Okay, but let me show you how you can reconstruct the table. Okay, this one I may not be able to write it, again, because I have to show you the book. So I can only say the answers. You have to write it for yourself, unfortunately. Okay, this is pi over 6, 2 pi over 6, or pi over 3. Okay, again, I'm doing number 5. They're asking stuff about pi over 3 and pi over 6. Okay, now, as I mentioned before, look at this point over here. Does it look like X or Y is halfway across the circle? Okay, if I look at X, that's way more than halfway. Y seems to be about halfway. So the Y coordinate is a half. And 1/2 is always paired with radical 3 over 2. No exception. It's a plus or minus, going around a circle. This one, picture's getting cluttered up. It looks to me like X is halfway across. Right? Y is definitely more than halfway across the circle if I go here. So X is a half, which means Y is the other number, square root of 3 over 2. All right. Now, based on that, they're asking for all this stuff. So 5a and b, cosine and sine, pi over 3. So cosine, x coordinate, 1/2. So let's see, little a matches with capital B. So you can mark that down on your notes. Okay, so one more time, for 5, little a is capital B. How about little b? Sine, y coordinate, radical 3 over 2. So little b is capital A. Okay, I'll let you figure out C is just y over x. And then D and E, 5D, 5E. 5D cosine of pi over 6, radical 3 over 2. So 5 little d is capital A. 5 little e, sine of pi over 6, y coordinate. Y coordinate is a half. So that's capital B again. So 5 little e is capital B. Again, little e, capital B. And I'll let you figure out F on your own. It's just a ratio. Okay, there aren't that many choices that are there, so I think you can figure that out. Okay. Okay, then we have a whole bunch of questions asking for cosine or sine of certain angles using the methods we had before. Okay, so we've seen this before, so we'll just try several more of these again. Okay, so how about I'll do for you what, 9? Cosine of 210. Cosine of negative 210. Okay, so I think we've played that game before. Sine of 210. Sine of negative 210. It's probably easier to do both of these at the same time and then both of these at the same time. Okay. So let's figure out where we're at. Okay, where's 210 degrees? Let's see, 90, 180, 210, quadrant 3, right? Quadrant 3, all students take calculus. Both the cosine and the sine are negative. So my reference angle is 30 degrees. Okay. So I take the values that I would have gotten at 30 degrees and make them both negatives. Okay. So go back to 30 degrees. I just drew the picture at 30 degrees here, which is pi over 6. Radical 3 over 2, comma 1/2, right? All right, so I'm in quadrant 3, so my answer is going to be negative. So cosine of 210, x coordinate, but negative. Negative radical 3 over 2. Sine of 210 degrees, look at the y coordinate, except again, make it negative. So negative 1/2. Again, why is it negative? Because I'm in quadrant 3, both x and y are negative, i.e. cosine and sine are both negative there. Okay, now how about negative 210 degrees? Okay, let's see, this is positive 210. So negative 210, let's see, negative 90, negative 180, and I come back, so I'm in the second quadrant, right? I'm in quadrant 2. Reference angle is still 30 degrees. The point on the unit circle corresponding to that 30 degree angle is radical 3 over 2 1/2. Let's see, the sine of the sine, S-I-G-N of the S-I-N-E, is positive, but the cosine will be negative. So cosine, I copy this except put a negative. Negative radical 3 over 2. Sine, I'm in a second quadrant, it'll be positive, so positive 1/2. So there we go. Raise it up so you can see it better. So negative radical 3 over 2 for both of these. This one's negative 1/2, this one's positive 1/2. Okay. All right. So that's what we're doing. Try 13. They give you 600 and negative 600. Secant, tangent, cosecant, cotangent. Okay. So let me write all these down. Secant 600 degrees. Cosecant negative 600 degrees. Tangent 600 degrees. Cotangent negative 600 degrees. So we have to figure out where we're at. $600. Okay, if I go all the way around a circle, that's 360 degrees, right? So if I go 600 minus 360, it's 240 degrees. I recognize that angle. So I go all the way around once, 360, right? Then I go another 240. So let's see, 90, 180, and then another 60 degrees. So it'll land me like this. Okay, so 360 all the way around, then another 240, 90, 180, plus 60. So my reference angle is 60 degrees. So reference angle of 60 degrees, which I showed you over here. Order pair is 1/2 radical 3/2. All right, so for A, secant of 600, secant is the reciprocal of the cosine. I'm in quadrant 3, so it should be negative. I take the negative of that x coordinate, cosines for x. So 1 divided by negative 1/2. The reciprocal of negative 1/2 is negative 2. Okay, so one more time, 360 all the way around, and then a little bit of preliminary work. I need to go another 240 degrees to get to 600, right? So there's 360, another 240, so 90, 180, another 60. Lands me in quadrant 3. That means both x and y are negative. Reference angle is 60 degrees. So I look for my reference angle at 60 degrees. The x coordinate was 1/2, which means the x coordinate in quadrant 3 is negative 1/2. Okay, so secant of 600 is the reciprocal of negative 1/2, which is negative 2. B, cosecant, oh, I'm sorry. Yeah, it's probably better for me to do C next. Sorry. As long as I'm thinking about a 600 degree angle, I'll just keep that. So tangent 600 degrees. Sine over cosine. Or y over x. So the y coordinate is negative radical 3/2. Radical 3/2. The opposite is negative radical 3/2. X coordinate is the opposite of this because I'm in quadrant 3. We know the trick that you can just cancel the 2's, cancel out the double negative, so radical 3. Okay, now I'll do B and D. I think it should have made more sense to do the 600s and then the negative 600. So let's see, I just did 600, negative 600. Let's see, negative 600, so negative 360, and then another 240 lands me up here, right? Again, a reference angle is 60 degrees. So reference, hence we refer back to the first quadrant, 60 degrees. And by the way, this was on that page that I showed you earlier, and you can put it on your cheat sheet. 60 degrees, the order pair was 1/2 radical 3/2 again. All right, quadrant 2. All students take calculus or ACTS or forecast. Okay, sine is positive, cosine and tangent are negative. All right, so what are we asking for? Cosecant. So now be cosecant of -600. Reciprocal of cosecant is sine. The sine SIGN of the SINE in the second quadrant is positive. So I want the reciprocal, positive reciprocal of that. Y coordinate 1/radical 3/2, which is 2/radical 3. And D, cotangent. Well, tangent can be thought of as y/x. So cotangent is x/y. So x coordinate, but negative because I'm in quadrant 2. So -1/2 divided by y coordinate, positive, because it's second quadrant, radical 3/2, cancel out the 2's, so -1/radical 3. Okay. So you see it's a little bit clumsy, but you have to kind of get used to these. All right, then they give us some in radian, so let me try some radian ones for you, like 17, 5π/4 and -5π/4. Okay. So A is cosine of 5π/4, cosine of -5π/4, sine of 5π/4, sine of -5π/4. All right, π/4 is 45 degrees. You want to get comfortable with that somewhat, I should say. Okay, mark off every 45 degrees. π/4, 2π/4, 3π/4, 4π/4, 5π/4, 6π/4, 7π/4, 8π/4, right? Let me just mark 2π/4, commonly known as π/2, 3π/4, 4π/4, commonly known as pi, 5π/4, 6π/4, commonly known as 3π/2, 7π/4, and then by the time I go all the way around the circle once, 8π/4, which is the same as 2 pi. All right, these are nice. Right there, π/4, 3π/4, 5π/4, 7π/4. Both x and y are radical 2/2. You just have to make sure you have the right sign, SIGN. Okay, so again, for the 30-degree marks, one of them is always plus or minus 1/2. The other is plus or minus radical 3/2. For the angles that have a reference angle of 45 degrees, like that one, that one, that one, and that one, they're both radical 2/2, plus or minus. So you just have to know where you're at. Okay, so I'm at 5π/4, quadrant 3. Cosine and sine are both negative. Negative radical 2 over 2. Negative radical 2 over 2 automatically. Okay, so this was 5 pi over 4. Now, if this is positive 5 pi over 4, a little bit more than half a revolution, right? So going the other way, going negative means I start down, end up over here, right? Negative 5 pi over 4. Quadrant 2. That's supposed to be a 2 there. Roman numeral 2. Maybe I should rewrite it. Second quadrant. Sine, S-I-N-E, is positive. Cosine is negative. Cosine is negative. Sine is positive. Okay. That's the way it works. Okay, and let me try to do a much messier one, like 21, to give you a bad angle and secant, cosecant, tangent, cotangent. Okay, so that's going to be a little bit harder. Let's take a look at that. Okay, so 21a, secant of 17 pi over 6. B, cosecant, negative 17 pi over 6. C, tangent 17 pi over 6. D, cotangent, negative 17 pi over 6. So where is 17 pi over 6? How do I figure that out? Well, so I see the denominator is 6. So let me get something that I'm familiar with. If I go all the way around the circle, that's 2 pi. How do you write 2 pi so that the denominator is 6? So I can figure out where I'm at. Well, multiply top and bottom by 6. 12 pi over 6, right? In fact, if you play this game again, split this up into 12, right? We said this is pi over 6, right? Pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, right? All the way around. And doesn't 12 pi over 6 reduce to 2 pi? Right, so keep going. 13 pi over 6, 14 pi over 6, 15 pi over 6, 16 pi over 6, 17 pi over 6. So 17 pi over 6, you go all the way around the circle and you land back here at another 5 pi over 6. So I land over here. Okay. Reference angle is 30 degrees. Either X or Y is halfway. Your picture doesn't even have to be that good. You can see the Y seems to be halfway. So that's a half. 1/2 is always paired with what number? Radical 3 over 2. And get the right signs, SIGN. Quadrant 2, X is negative, Y is positive. All right, so A, secant 17 pi over 6. Secant is the reciprocal of the cosine. Cosine means x coordinate, right? X comma y, cosine theta, sine theta. It's always alphabetical. So x coordinate is negative radical 3 over 2, 1 over negative radical 3 over 2. Flip it, negative 2 over radical 3. Right? And yeah, let me go do C since I'm already on this. Tangent 17 pi over 6. Tangent is y divided by x, one of the formulas. You can put that on your cheat sheet. So I just take the ratio of y to x. So y was 1/2. X is negative radical 3 over 2. Negative radical 3 over 2. And we know the trick that you can just cancel out the 2's, right? So negative 1 over radical 3. And you can leave it. All right, then B and D, negative 17 pi over 6. Okay, so I have to keep track. Let's see if I go all the way around once and then almost a half, not quite a half. That's 17 pi over 6. So I have to do the same thing going backwards now. So how do I do the same thing backwards? So let's see. All the way around, not quite half. Okay, so negative all the way around, not quite half. That lands me over here. Right? Backwards, a full revolution and not quite a half. So this reference angle again is 30 degrees. Okay. Both x and y are negative. The y coordinate is halfway down, so negative 1/2. Notice if you do it the right way, your picture doesn't even have to be that accurate. I didn't even use a ruler for that one, just so you can show you it shouldn't matter. The x coordinate looks like it's way more than halfway, but the y looks like it's more like halfway. So this is negative 1/2. It's always paired with radical 3 over 2. And since we're in quadrant 3, they're both negative. All right, so now B, cosecant. Cosecant of negative 17 pi over 6. Cosecant is the reciprocal of the sine. So I flip the y coordinate, negative 1/2. 1 divided by negative 1/2. The reciprocal of negative 1/2 is negative 2. And finally D, cotangent. Cotangent is x over y. Tangent was y over x, right? So cotangent is x over y. Cotangent, negative 17 pi over 6. I'll write it down, x over y. So the x was negative radical 3 over 2. Negative radical 3 over 2. The y coordinate is negative 1/2. Cancel the 2's, cancel the double negative. Radical 3. Okay. All right, we're going to break. And then after the break, I'll just do a few more problems. And then if you have questions pertaining to the exam, you can bring it up with any of us, Mackenzie or Star or myself. If not, then I'll probably just let you go. Okay, so we'll break as usual until 12:10. I won't lecture that much longer after 12:10, and then we'll review for the exam if you wish. Okay, all right, so break time until 12:10. Okay, folks, let's continue where we left off. All right, so I was just going to do very little more. I only have maybe a couple more problems to do, and then it'll just be a review session after that. Okay, and so we have both Star and Mackenzie with us. So Star and Mackenzie, if you want to tell the class any availability you have in preparation for the test, I know you each of you mentioned something about it. So if you want to put it in email or send a Canvas announcement or put it in the chat right now, that's up to both of you. So Star and Mackenzie, if you want to tell the class for preparation for the test on your own, you may. And I'll blab just for a little bit longer, maybe 5-10 minutes. And then it'll be an optional question and answer session. You can all stay, you can all leave, or one or two of you can stay, or half of you can stay. I guess by the principle of equivalence, by equivalence, think of what happens if we were meeting face-to-face on campus, right? And I'll just say, okay, you can stay and ask questions. If you don't have any questions, then the three of us, right, Mackenzie and Star and myself would stay. So if you all walked out, you know, that's fine. Or if everybody stays and asks questions, that's fine. Or 10 of you stay, you know, hopefully, you know, we wouldn't be offended by how many stay or leave. I mean, if all of you decide to leave, then fine. I guess it just makes it easier on all of us. So what I'll do after I finish blabbing for another 5 or 10 minutes is split you into breakout groups like last week. Okay, and half of you will be with Star and half of you will be Mackenzie, and I'll be in the main room. So if anybody wants to come catch me in the main room, you may. But if you don't want to stay in the review session, you can just leave. And then what I'll do for Star and Mackenzie is if one group gets to be too many, then I'll just move somebody around. So be ready for me to move you. Again, thinking of face-to-face, if we were face-to-face and, you know, if there's 6 people left and they're all in one of you, then that's not efficient. It'd be more efficient if we mix it all up. So at the beginning, I'll split half of you with Mackenzie and the other half with Star. But if it gets to the point where, you know, one of them has nobody and the other has 5, then I might move some of you over. And then anybody who feels like they want to come back to me, you can, you know, ask me stuff also. Okay, so that's the way it'll work for today. And I'll leave it up to Star and Mackenzie to contact the rest of you for when they're available besides today, you know. So a quote unquote review session is now after I finish talking for the other few minutes between now and 1 o'clock. So that's automatically a review session. And then I'll leave it to Star and Mackenzie to give you other times that they might be available in preparation for this Thursday's test. Okay. All right, so I'll go right to it. So if you think to yourself, if you already have in your head, okay, I want to go over this concept and this concept and this concept, fine. But if you already say to yourself, I don't need a review, I'm good, then after I finish blabbing for another 5 or 10 minutes, then you can just leave, okay? All right, so I'm gonna go back and do the last few problems, which will not take me that long to do. Okay, something like 23 and 25, and then that would be just about it. Okay, and let's see. Okay, so let's see. Okay, so Mackenzie's put something in the chat, so thank you, Mackenzie. And it's up to you, Star, if you want to do likewise, but you don't have to. Do whatever's more comfortable with you. And let's see. And Star has something also, so thank you, Star. So, right, so we're, as you know, we're blessed to have, you know, 2 great helpers for our class, our embedded tutors. So thank you very much for Star and Mackenzie to help us and help me as we go through this semester. Okay, so let me go ahead and do some of these other ones, and then that should be just about it. So 23, show you what it says. List 3 angles in radian measure that have a cosine of -1/2. Okay, so what does that mean? 3 angles, cosine of that angle is -1/2. All right, so All right, cosine means the x coordinate, right? So remember, when you go x comma y is cosine theta sine theta. So x coordinate is -1/2. So I go halfway like that. And then I try to draw my angles, which are like that. And there's another angle like that. All right, now in the directions it says radian measure. You want to be comfortable in radians and degrees, frankly. Okay, but in any event. All right, so what is this angle? Probably more comfortable in degrees. So in degrees, that looks like 120 degrees. Now, what is that in radians? I mean, one way to think of it is start off again with a basic 30-degree angle. It's worth knowing that 30 degrees is pi over 6. And then I just count. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3. Okay, now how about this angle here? In degrees, this looks like 180 plus 60, 240. Right? Now, what is that in radians? Well, this is 120. 120 is half of 240. So one thing you can do is just double this. So what's 2 times 2 pi over 3? 4 pi over 3. Okay, so that's 2 angles. A third angle, well, you have a choice. You can go all the way around the circle and then come back. Or I can go negative. In this case, it might be easier for me to go negative. Okay, that looks exactly the mirror image of this. So that would be -2 pi over 3. Okay, there's actually infinitely more angles at work. Okay, but that's good enough for now. So how about 2 pi over 3, 4 pi over 3, and -2 pi over 3. All right. All right, so that's 23, and your 25 is similar, and I think I'm done. So 25 is very similar. So there we go with that. Okay, all right, so I'm done with what I was going to do today. And what I'm going to do right now is break all of you in half. Half of you with Star and half of you with Mackenzie, but you don't have to stay if you don't want to. But please wait until I set the breakout groups. And if people disappear, that's fine. I hope that Star and Mackenzie, we're not going to feel badly if you all disappear or whatever. Again, think of we're helping anybody who wants to stay. So I think of equivalents if we were meeting face to face inside a classroom, and to say, okay, whoever wants to stay, you can stay, and if you don't want to stay, you can leave. And then if half of you leave, or 2/3 of you leave, or only 3 of you stay, that's fine. Or if you all walk out, that's perfectly fine with us too. Okay, so I'm going to stop the share. And I also believe, yeah, I think Star and Mackenzie, I've figured out how to give you screen share capabilities. So you can try it if you want to, if you wish.